Okay, next video is on how to read acceleration graph, meaning v versus t. So again, acceleration is v versus t is how v changes. So v final minus v initial over change in t. So if we find the slope of this graph v versus t, we will be able to say what the acceleration is. If you look at the graph that's in your screen, you see that velocity changes throughout the time. The total time is 20 seconds and velocity fluctuates, and we can see specific points where this is speeding up. We know that because we have the increase in velocity from 0 to 30 within 5 seconds. So we could figure out acceleration 1 to be 30 is the final, 0 is initial, and 5 is the total number of seconds that elapsed. So that would give us 6 meters per second squared. So something, whatever this is speeding up from 0 to 30 meters per second in 5 seconds. Then this is not rest even though it's flat, so this is constant v, and it's going at 30 meters per second constantly for the next 4 seconds. So this could be considered as your elapsed time change in t equals 4 seconds. And then in the next 3 seconds from 9 to 12, what we see here is the slowing down. This part of the graph right here shows us the decrease in velocity from 30 to 0 in 3 seconds. So if we were to figure out the acceleration here, I'm going to say acceleration 3, acceleration 2 was 0 because velocity wasn't changing, but acceleration 3, we ended up with 0, started with 30, and it took exactly 3 seconds. So acceleration was negative 10 meters per second squared. That's a lot. And then we see that there is a flat part at 0. It could be not moving at all, or it could be making a U-turn. And in our case, it is making a U-turn. We know that because velocity went from positive to negative. So what you see is after 15 seconds, for the next 3 seconds from 15 to 18, our object is speeding up in the opposite direction. So it's sped up from 0 to negative 20. So acceleration here will be negative, even though we're speeding up. Negative 20 is the final, 0 is the initial, and it took 3 seconds. So about a little bit under 7 meters per second squared with a negative sign because it's speeding up in the wrong direction. And then it hits again, not rest, but consistent flat negative 20, so it keeps going at negative 20 meters per second, not accelerating, so acceleration is 0. So overall, if we were to find the average acceleration is the total change in velocity throughout the total time. The total time here is 20 seconds. Your initial, this is your v initial at 0, and then this is v right here, this is v final. So v final is negative 20 minus 0, so overall our acceleration is negative 1 meter per second squared. Now what if we were asked to find average velocity? So we see that our velocity goes from 0 to 30, then it stays at 30, then from 30 to 0, then there's a U-turn from 0 to negative 20, then sometime at negative 20. So we have a number of different velocities, and in math, when we find average, we kind of add everything together and divide by the total number of numbers, and then that gives us average. Not in this case. Average velocity, or average speed for that matter, is displacement over time for velocity, or distance over time for speed. Area under the graph, so the area of this trapezoid right here, would be our positive displacement because the object is moving with positive velocity. It's changing, but overall, if we find this area right here, we will be able to figure out what the displacement was. And the way you do it, you can split it into a rectangle and 2 triangles. That's fine. Or you can remember the trapezoid formula. For area of the trapezoid is 1/2, and then you have your base 1 plus base 2 times height. So in our case, we have the total base at the bottom is 12 seconds. The top base is only 4 seconds. So we would do 1/2 of 12 plus 4, which is 16, so that gives us 8, and we multiply it by the height, and height in this case is this right here, that's 30. That's 240 meters. That is displacement in the positive direction. That's going whichever way it is, north, south, east, west. That will depend on your data. And then if you look at the second part, that is also a trapezoid, or you could have split it into a triangle and a rectangle. That's up to you. I'm just going to treat it as a trapezoid. And that trapezoid is looking down. It is under the x-axis, so that displacement is negative. It's in the opposite direction. Again, we can find this as 1/2, and we have one base of 2 and one base of 5, so that's 7. 7 over 2 is 3.5, and we multiply that by 20, even though it's negative 20. But I already said that we have a negative displacement here because it's in the opposite direction. That trapezoid is looking downwards. 3.5 times 20, that's 70. Or you could have done it this way. So this is 7 times 20 over 2. That's 140 divided by 2, so 70 meters. And this is negative because it's in the opposite direction. If we're looking for v with an arrow, meaning that this is our average velocity, we will take our total displacement, so direction matters, over total time. Total displacement will be, we have 240 in the positive direction and then 70 in the negative direction, and the total time is 20. So that gives us 170 over 20, so that's like 17 over 2. That is going to be 8.5 meters per second. That is our average velocity, and that is in the positive direction because our overall displacement was in the positive direction. We had 240 in the positive direction, 70 in the negative. Now, if we were to find speed, so speed is very much like velocity, only instead of total displacement, we'll take total distance over total time. And distance in this case, it doesn't matter which way we were going. We went 240 one way and then 70 another. So for distance, we will add these two. So 240 plus 70 over 20. So that will give us 310 over 20. So that's like 31 over 2, and that gets us 15.5 meters per second. Slightly more, right? We will say V average for velocity will be 8.5 meters per second, and you can add positive, or if you knew the direction, you will add the direction. So let's say positive was west, you will say west. But then for your speed, there's no, so this one will not be written for speed. You won't do that. You will just say V average without the arrow, and then that will be our 15.5 meters per second in no particular direction because speed does not have the direction. So that's how you read and how you interpret the graph. Again, we had V versus T. We saw that our object sped up, slowed down, moved with a constant speed. It changed direction. There was a UE. So that is our U-turn right here. And all that we can analyze and answer several questions regarding constant accelerations, acceleration through a certain period of time, average acceleration, total displacement we can find, total distance we can find, average velocity, average speed, all that good stuff. So hopefully this helps.